right, here we go. We're doing this review for the Unit 5 test coming up on Monday. So we're given a table representing some points in the graph of exponential. So remember, exponential is a times b to the power of x. So when we're given a table like this and we want to find which function, we want to get an equation from a table to the equation, right? What we need to do, we need to go to Desmos, hit the plus sign, and then type in this table. And then we're going to go down a line and we're going to type in this exponential function, except it's going to look like this. Y1, instead of equals, it's a squiggle, a, b, and to the power of x, 1. So the little ones are next to x and y. Squiggle is instead of equals. So let's go ahead and put this into Desmos. Fine, table. Okay, 1, 2, 3, 4. All right, so I typed it all in. Remember, each row is a column. And then, like I said, y1 squiggle ab to the power of x1. Make sure x1 is in the exponent. Now, it's going to give us an a value and a b value. So look, my a is 1232. My b value is 1.5. Now you know you can just type 1.5 here, and then it'll give you this little fraction bar, and it'll give you the fraction, which is 3 over 2, right? So that means if my equation is a times b to the x, it's going to be 1232 times 3 over 2 to the x. What answer matches that? Letter D. Okay, so you got to be able to take these tables, hit the plus sign on Desmos, type it in, y1 squiggle ab to the power of x1. Number 2, Jerry Jones recently gave himself a pay raise. His starting salary was $1,000. Okay, so my a value, sorry, $1 million. Okay, after 1 year, his salary grew to $1 million and $1,002,000. If his salary continues to grow at this rate each year, which function can be used to model his salary X years after he began his raises? Okay, so remember, if it's y equals a times b to the power of x, so I'm looking at these, if my a value that he starts with is $1 million, then it can't be 1,002,000, it can't be C or D, right? So now I see these answer choices have a fraction here, so which fraction is correct? Well, you put the new over the original, the new over the old, okay? You got to know n over o. So the new 1,002,000 over 1 million. That's your rate, okay? And you'll get like 1.002, but it's not asking for the decimal or even the reduced fraction. It's just asking you for the new over the old. You can leave it like that, okay? So this is my b value. So what would it be? Y equals 1 million, and then 1,002,000 over 1 million to the power of x. So the best answer is A. Cool. All right, and you can also tell because it's increasing each year because it grew, and the fraction has to reduce to something greater than 1, right? 1.002 is greater than 1. Yet this over here is not going to be greater than 1. It's not going to grow. An exponential function is graphed on the grid. Which function is best represented by the graph? Okay, well, remember y equals a times b to the x. A is my y-intercept, right? So a equals 4. So all of these have 4, but I want you to notice a times b means there is no plus sign. Like this plus sign stuff is weird. There is no plus sign in exponential functions. It says it's exponential. You see the curve. It's not linear, so it couldn't be. I mean, it's just not plus like that. Okay, we're not doing shifting up and down this here. Okay, so C and D both have 4 as a value. The question is what's happening each time? So from 4 down to 2, is that multiplying by 2 or multiplying by half? Well, you might already see that it's half because it's going down. It's dk. That means your b has to be less than 1, and only 1/2 is less than 1. But let's say you're not sure. You could also just graph and check the answer choices. I mean, you could even graph A and B and check it, okay? Let's graph C and D. So y equals 4 times 2 to the power of x. Now, does this graph on the right look like this graph over here? No, does not. But if we change that to a 1/2 on the inside there, now that looks right. There's 4. What about right here? It's about 1 comma 2. 1 comma 2. Hey, that's right. So D is the correct answer. There's a couple ways to do it. You can compare and think about the equation. You could also graph and check. Okay. All right. When a new skateboard is released, its price is $60. Okay. So again, y equals a times b to the x. A is initial. It tells us the initial price is $60. Now the price is expected to decrease by 4. Okay. Now let me back this up. This is what we did the last couple of days. It's 1 plus or minus the rate. Okay. So my R value is 4%. And y'all remember how to convert 4%, right? You move the decimal 1, 2 to the left, and this space has to have a 0. So 0.04. Okay. Well, all I got to do now is write my equation and then simplify it. Y equals A, so 60. 1, now hold on, plus minus, which one is it? This word decrease tells me exactly what I need to know. It is going to decrease, so it is going to subtract 0.04 to the power of x. Please notice it is not 0.4. That would be 40%. Okay. Well, now none of these answer choices look like this exactly. So let's do the math. What is 1 minus 0.04? 1 minus 0.04 is 0.96, okay? 0.96. Well, now I have an answer, right? Uh, this doesn't match. This doesn't match because on these, x is not in the exponent. And then on this one, it looks like they added instead of subtracting. That's a big distractor. It's not D, it's B because we are decreasing, not increasing. Decrease. subtract. Okay, well, cool. Number 5, the company currently has 400 employees. Currently, initial value, my A value is going to be 400. Morale is at an all-time low such that a number of the employees is expected to decrease. The number, no wait, it is, my bad. The number of employees is expected to decrease at a rate of 3% each year, right? So R equals 3%. Move that 2 to the left. 0.03. Write an exponential function to model the number of employees in the company. Well, just like last time, okay, my function is y equals a 1 plus or minus r to the x. And again, when I see the word decrease, I'm subtracting. So y equals a, 400, and then 1 minus 0.03 to the power of x. Now, I want to write my answer in here. Okay, just remember, 1 minus 0.03 is not ideal. What is 1 minus 0.97? So it's going to be 400, 0.97 to the power of x. All right. So please remember, when you have a rate and you're increasing or decreasing, you're adding or subtracting that from 1. All right, what is the equation of the asymptote? Okay. Asymptote of the function that we talk about this here is always going to be what? We said that the asymptote is always going to be y equals 0. Remember, you got your graph, and it's on that x-axis at y equals 0. That is the line that it does not touch, okay? No matter what it is. Alrighty. A customer purchased an electronic device for $7.25. Each year the value of the electronic increased by 20%. So y equals $7.25. 1 increase is plus 20%. Do we know what that is? Move it 2 to the left. 0.2 to the power of x. And then if you do the math, 725, 1 plus 0.2 is 1.2 to the power of x. Cool. Now, let's answer the question. Which statement is true? Which is true, not false. So is the y-intercept 20? So remember, y-intercept is going to be right there. Is that 20? No. The horizontal asymptote. Now remember, we just did that up here, and it's always going to be y equals 0. So it's definitely not x equals 20. No. The rate is 725. Now remember, the rate is supposed to be right here. That is not 725. So is the y-intercept 725? Well, yeah, y-intercept is supposed to be this, 725. That's good. Okay, so please be careful when you're doing this. Which statement about this graph is not true? Not true. Very important. Let's read it. Is the y-intercept 0, 4? No. The graph is exponential decay. Decay is when your b is less than 1. So is this b less than 1? That one's true. The graph does not intersect the x-axis. So remember, all these exponentials do not touch the x-axis because there's an asymptote there. So that's true. And the graph has a horizontal asymptote at y equals 0. Remember, I keep saying it, the asymptote is always y equals 0. So that's true. Well, which one's not true? A. All right. Number 9. An exponential function has these characteristics. Y-intercept is 1, decreases at a rate of 50%. So y equals 1. And then you always put 1. And if it decreases, it's a minus. And hopefully we know 50%, 2 to the left, is 0.5, right? So 1 minus 0.5 to the power of x. You can simplify inside the parentheses, and you get y equals 1. 1 minus 0.5 is 0.5 to the power of x. Now, I would just graph it and compare. Okay? Or you could look at it. Which one of these has a y-intercept initial value of 1? Okay, A is good. This is not it. Not B. Okay? C is at 1. That's good. 2. Okay, this one's not at 1. So that ain't it. Okay? And then if it's 0.5, it's decreasing. Look at A and C. Which one's decreasing? This one's increasing. That ain't it. So I can tell you it's A just by what I know about the equation. But please try and graph it. It's 1, 0.5 to the x. And if you look at that, that looks good, right? It's at 1. It's decreasing. It is A for sure. Okay. All right. Last one, number 10. Now I had to squeeze it on the page here. So again, number 10 is over here. What is the graph of the function 9 times 1/3 of the x? 9, 1/3 to the power of x. Okay. Now, again, you can graph and compare here. And this one you're going to graph in Desmos and then get a table. How do you get a table? The widget, hit the table button. Okay. So you got your table right here, 0, 9, 0, 9, 1, 3, 1, 3, 2, 1, 2, 1. Okay, and you can see that it's decay. It never will cross this line, right? So it's going to go through those 3 points and then level out. Okay. You're going to do this on the computer on the test, so you're going to be clicking points to graph it. All right. But that is your review. That's how you do everything in the test for sure. Please look over how I did each step. Remember what you need to remember, like y1 squiggle at ab to the power of x1. And remember all the little things we talked about on here, all the formulas, etc. All right.